Welcome, and in this video series we're going to look at linear and quadratic functions. So really all we want to be able to do is identify properties of each of these functions, and when I use functions, again, that's going to be in terms of x and y, or two variables in general. Don't really care what they are. And so we're going to look at linear functions in this video, and then later videos are going to look at quadratics. Okay, just note that in our Hawks assignments, 4.2b is listed as due, but what that really means is that it's going to be optional. Okay, if you are taking pre-calculus or plan on taking pre-calculus or continuing in math, I strongly encourage you to go through those videos and complete those, as well as the online Hawks assignment. And then I'll mention there's a little goodie that accompanies the 4.2b Hawks assignment, but I'll mention that in class. All right, let's talk about linear functions. Okay, these aren't going to be radically different. We've already looked at linear equations in two variables, so that's like something like your famous y is equal to mx plus b, or any variation thereof. And we've looked at these, and I think it's safe enough for us to say that these linear functions, when you graph them, or these linear equations rather, are linear functions. And so the idea with that, at least when we use that language of function, remember that there was a definition that went with that. For every x value, there's one y value associated to it. And or another way of saying that is it passes the vertical line test. Okay, and I need to make my graph just so it's a little bit smaller here, so let's do that. So if we can imagine, like, here is our line, or we could have something like this, right? And if we take a vertical line anywhere through there, we hit the graph of it at most once. So that's enough for us to call it a linear function. All right, and so everything that we learned, we can just say, or from linear equations, we can talk about that in terms of linear functions now. And then just so you're aware, the book calls these functions first-degree polynomial functions. Okay? When we talk about these as functions now, there's actually another property that goes in with them, and this isn't in the textbook per se. I will assess you on it, and it'll appear in activities and that sort of thing. And this is more to benefit you when you get into pre-calculus, and again, I'm assuming everybody's going to take pre-calc. But anyway, we talk about a function being either increasing or decreasing on a particular interval. So this would be like, I don't know, maybe like minus infinity to 3 or something. It would be some range of x values, right? If, and now here's the technical language, if for any 2 points, x1 and y1, in that interval, we have, so if we look left to right, we have that it is also rising. Okay, so really increasing is as you go left to right, as you go this way in the graph, is it going up? Okay, so, or in linear functions, it would be equivalent to, does it have a positive slope? Okay, but this, you'll see, we're going to use this both in linear functions, in quadratic functions, and in the other functions that we discuss as well. So there's increasing. Decreasing is similar. It's just the only thing that changes is that as we progress to the right, we have that the y values are shrinking in value. So that would look something like, as we progress left to right, we are falling vertically. So like here might be that first point x1, y1, and then down here might be that second x2, y2. And so we see that certainly it's the case that x2 or x1 is less than x2, right? So we're going to the right. And then when we do this, we also have that y1 is bigger than y2. So that fits the idea of decreasing. Okay, so make sure to say, when you're talking about increasing, decreasing, we're talking about intervals, so make sure to identify that interval. And then in my example here, it would be all real numbers. Okay, or if you want to say double bar r, that's fine as well. All right, so just to verify this, let's do an example. And so here, this is a linear function. We want to identify its slope, intercept, blah, 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 blah. Okay, and so here, this f of x, we might remember that's really the same as y, and really a function is just a way to get the y value. So, and if we write this a little bit differently in slope-intercept form, this would be y is equal to minus 2x plus 3. Now, either, if you need help generating the graph, certainly make a table of values, so you could do like x, y, and then I always pick -2, -1, 0, 1, and 2 for fun. But really, what I'm able to do is say, okay, well, my y-intercept, my vertical intercept is at the point 0, 3, and I'm just going to put that on here as a point. And then to get another y value, I would just kind of follow the slope. So I would go down 2 to the right 1. And this leads me to the point 1, 1. And for a line, 2 points is enough. So I would say, okay, here's my rough sketch of the graph of the linear function. Okay, and I would label it y as, or let's actually label it as f of x is equal to 3 minus 2x. Okay, so then I have all this other stuff to do. Slope, okay, that's just the coefficient of the linear term, so this is -2. Intercepts, I found one, so intercepts are going to be at 0, 3, and then I need to find the x-intercept. That's going to look a little different. So that one I maybe need to find algebraically. So if I'm finding the x-intercept, I need to set y equals 0 and solve. Okay, let's move that over. -3 is equal to -2x, and then I have 3 over 2 is equal to x. So then that's the x value, and then the corresponding y value is 0. Okay, and now in terms of intervals of increase and decrease, increase, well, is it increasing anywhere? No, it's falling all the time, so I'm going to say none here. And then decrease is going to be, you can see as you progress left to right, the graph is falling vertically, so that means it's decreasing on its entire domain of -infinity to infinity. Okay. Now my claim is that a line, if it has a non-zero slope, it's either increasing or decreasing. Okay. Horizontal lines, actually, you would have no intervals of increase nor decrease. Okay, so here is an example, or here's another question that you're going to answer in a quiz here shortly, and I want you to do your best with it, and then we'll talk about it in class.